In part one of this lesson, we're going to review concepts that we learned about quadratics when we were in grade 10. Specifically, we're going to take a look at properties of parabolas or quadratics. We're going to look at the axis of symmetry, the vertex, direction of opening, and the x-intercepts. And we're going to also remember how to solve quadratic equations. And we know we can solve them by graphing, factoring, and using the quadratic formula. In part two of the lesson, we're going to look at some application problems and model situations with quadratic relations, and then we're going to solve them. So here are some important properties of a parabola. We've got the vertex. The vertex is going to be the lowest point or the highest point, depending if the parabola opens up or if it opens down. The axis of symmetry. The axis of symmetry is going to cut that parabola exactly in half. Also, the axis of symmetry is where the vertex is going to be. So wherever the axis of symmetry intersects with that parabola, that's where we find the vertex. And then we have the intercepts. We have the x-intercepts and the y-intercepts. We can always find y and x-intercepts by substituting in 0 for x or for y. So for example, in order to find the x-intercepts, all we have to do is set y equal to 0 and solve. And in order to find the y-intercepts, we know all we have to do is set x equal to 0 and solve. So let's quickly find the axis of symmetry, vertex, and maximum and minimum of each of these graphs. Okay, so let's start with this first guy. The axis of symmetry we know is going to cut the parabola exactly in half. So it's going to be this line right here. And visually we can see that that's going to cut it exactly in half. We can prove that this is going to cut it exactly in half. By the way, what is this number? This is 1. Okay, so this is the line, then x is equal to 1 because that's what's true along all this entire line. X is always equal to 1. So that's the axis of symmetry. It's not always so easy to tell. So we know we can prove that that's the axis of symmetry by taking two equidistant points, so 2 points out of the same y value, and take a look at their x values and just find the average of them. So the 2 points that we usually use are its x-intercepts if the parabola has x-intercepts. So in this case, we have one x-intercept at a value of -2, and we have another x-intercept at the value of 4. So to prove what the axis of symmetry actually is, the thing that's right in the middle of it, all we have to do is we have to find the middle of these two numbers. And the mathematical way to find the middle of those two numbers is to just find an average. So I'm just going to add them together and divide by 2. So we have -2 plus 4 and divide by 2. -2 plus 4, that's just going to be 2. And when we divide that by 2, we're going to get 1. So there's our axis of symmetry. Our axis of symmetry is x is equal to 1, and it's this line right here. That's going to give us an indication of what the vertex is now, because we know the vertex lives on the axis of symmetry. So the vertex is right up here. So even without a graph, we can tell what this coordinate is going to be. We can tell what the x coordinate is going to be. It's going to be 1, because it has to be the same as the axis of symmetry, because it's perfectly in the middle of the parabola. We can mathematically find the y value if we have the equation, but visually we can just count it, that y value has to be 9. So our vertex is just 1, 9. And last, what is the max or min value? What does that mean? This means that a parabola is either going to have a maximum or a minimum value. It cannot have both. So in this case, this parabola opens down. So it has a highest value. It has a maximum value. And what is the maximum value? That maximum value comes from the vertex. And is the maximum value 1 or is it 9? Well, is the highest value of the function 1? No, that's just the x value here. And 1 is definitely not the highest x value. The x is an element of r for this function. The highest or maximum y value, it comes from the y value. That's 9. So that means our max value, we don't want a highlighter. Here we go. Our max value is equal to 9. So each parabola will have either a max or a min, not both. So now that we've reviewed that, hopefully you remember it all from grade 10, try this guy on your own. Pause the video, do it on your own, come back to check your answer. All right, hopefully you've got answers, you know what to do. Let's just take them up really quickly. First of all, the axis symmetry. This is a nice, easy graph that we can just read what the middle of the graph is going to be. The middle of the graph, or the vertical line that's going to cut this graph in half, is at x equals -5. We can prove that algebraically by taking the two x-intercepts. Those are equidistant from the axis symmetry, and what we're going to do is just going to find the average of them, add them together, and divide by 2. Boom, here we go, -5. So that axis of symmetry is not -5, it's in a line. It's x equals -5. That vertex here, we knew that -5 from the axis of symmetry. Those two numbers are going to be the same. The y value we can just read off the graph, that's -4. This parabola opens up, which means this point is the smallest value of y. This parabola does not have a maximum. This y value is going to continue on to infinity. So this parabola has a minimum value, and that minimum value comes from the y value, -4. So note the max and the min, they both come from the y value. Let's quickly do one last easy example. So we have this equation of a parabola. We know it's going to be quadratic because the degree is going to be 2 if we expand that guy. It says find the vertex of the parabola. All right, how the heck are we going to find this vertex? First of all, we know that this parabola is going to open up because the a value is positive, so it's going to look something like this. It's going to open up. This is not in vertex form. If you can't remember vertex form, don't worry so much, we're going to go over it. But what we can do is use what we learned on the first page, which is that we can always find the vertex by first finding the axis of symmetry. And the axis of symmetry is going to come from, if we have 2 points, what's helpful is the zeros. If we have the 2 zeros, we can just add them together, divide by 2. So can I find the x-intercepts? If I'm going to find the x-intercepts, I have to plug in y is equal to 0. So I'm going to start with that. So let's start with y is equal to 0. So I have y equals 2, x minus 4, x minus 2. Now this was already factored for us, so we can just pull out the answers. Because we have one side equal to 0, I can just pull out my two solutions. My two solutions have to be +4, and my second solution has to be 2. Again, quick recap, we're just guessing and checking values here so that the whole thing is equal to 0. So if I put in a 4 here, 4 minus 4, everything becomes 0. If I put in a 2 here, 2 minus 2 is 0, everything becomes 0. Okay, so these are my two x-intercepts, so I'm just going to add them to my chart here, or my graph. So I have one x-intercept is at 4, one x-intercept is at 2. Okay, so this is going to be a skinny parabola. Here we go. Okay, let's find the axis symmetry of these things. So I want to find the line that's going to cut it in half. Clearly it's going to be at 3. Okay, if we weren't sure, we could just find it algebraically by adding them together and dividing by 2. 4 plus 2 divided by 2, that's 6 divided by 2, that's going to be 3. So we know that our axis is x equals to 3. So that means that my vertex has to lie somewhere on this axis. So in order to find the vertex, all I have to do is plug in. We already have the x value at the vertex. We're just going to find our y value. So I'm going to plug in that x value to find the vertex. So I'm going to plug in 3 every time I see an x. 3 again. I'm going to solve for this vertex. So I have 2. 3 minus 4 is -1. 3 times 2 is 1. This is going to give me -2. So my vertex should be, my x value has to be 3 because that's where my axis of symmetry is, and my y value has to be -2. So I'm going to plot that right here, and I have my 3 points. If I connect it, it should make my parabola. Ta-da! This parabola opens up, and that's exactly what I predicted would happen because my a value is positive. Now let's get to reviewing how to solve quadratic equations. So we know how to solve equations. We're just going to get x by itself. But sometimes with quadratic equations, we get stuck when there's more than one x. So there's 3 ways that we can solve quadratic equations. One is just regular solving. So if there's only one x variable, we're going to do exactly what we do with linear equations. We're just going to get that x by itself by doing opposite operations. If that doesn't work, we can factor. And if it can't be factored, that's when we can use the quadratic formula. So any of these methods can be used. So if you can't remember the quadratic formula, here's the quadratic formula. You can only use the quadratic formula when you have a trinomial that equals 0. Your a value is the coefficient of x squared. The b value is the coefficient of x, and the c value is the constant. And what we're going to do is we're going to plug it into this equation, and it gives us the solutions to x. So we're going to keep that in our back pocket. Factoring and just regular solving is usually quite faster. So if we can use these two, we're going to, and if worse comes to worse and we can't solve it, we're going to use the quadratic formula. So let's take a look at these examples. How about this guy right here? It's definitely quadratic because if I expand this, this is x minus 1 times x minus 1, and x times x is going to be x squared. We only have one x variable here, so there's no need to factor or use the quadratic formula. I can just isolate for x. So instead of expanding this, if I expand, I'm going to have more than one x value. Let's just get x by itself. So let's start by removing the 10. So I'm going to get rid of that minus 10 by just adding 10. So I'm going to kick that 10 onto the other side, and my equation is going to become 2x minus 1 all squared is equal to 8 plus 10. So I've got 2x minus 1 all squared is equal to 18. My next step, do not square root, because if you want to square root, that's fine, but you're going to have to square root this entire side and this entire side. And the reason why I don't want to do that is because I don't want to square root 2. That's not a nice number. So let me carefully erase this. I'm not going to square root. It's not going to make for nice math here. Instead of square rooting, let's just get rid of that 2. How do we get rid of that 2? We're just going to divide. So I'm going to divide by 2 on both sides. The 2's will cancel out, and I'll be left with x minus 1 all squared. Oops, x minus 1 all squared is equal to 9. Now I can square root it because I've got nothing that doesn't square root nicely here. So I'm going to square root it, and I have x minus 1 is equal to the square root of 9 is 3. Have you noticed we've made a mistake? This parabola should have 2 roots because we know that if we were to graph this thing and we graphed this parabola and we checked when it was equal to 8, there would be 2 solutions to this, but we're going to get one solution. Where do we make the mistake? We made the mistake right here when we created the square root. When we create the square root, we got to put a plus or minus in front because there's 2 solutions. So the square root of 9 could be positive 3 and it could be negative 3. So we've got 2 cases here. One case is if x minus 1 is equal to positive 3, and one case is if x minus 1 is equal to negative 3. So our first solution would be 3 plus 1, which is 4. Our second solution would be negative 3 plus 1, which would be negative 2. So these are our 2 solutions to our quadratic equation, and the only technique that we used was just regular solving. Before we keep going, let's just remember again the different ways we can solve quadratics. Regular solving, that way worked. We can also try factoring and using the quadratic formula. So let's keep that in mind, and let's try this next guy right here. All right, solve this. Okay, so maybe you're thinking, oh, I can just factor that. I can just factor this to x minus 3, negative 2. All right, if you factor that, that's fine. But what are you gonna get from it? What can you plug into x here to make this whole thing equal to negative 2? That's a really hard problem. The only time factoring is helpful is when one side is equal to 0, not when it's equal to negative 2. So this is just not going to work. So I'm going to erase this guy. Okay, can we use regular solving techniques? No, because we've got 2 x's. We're never going to be able to get x by itself. So we have to try factoring or the quadratic formula. And to factor, it's only helpful if one side is equal to 0. So we're going to send this negative 2 onto the other side. And we've got x squared minus 3x plus 2. All right, can we factor this guy? Yeah, we can try sum and product. Let's see. We need 2 numbers that multiply to 2, add to negative 3. It's going to be negative 2, negative 1. So we've got 0 is equal to x minus 2, x minus 1. And because one side equals 0, this is an easy guess and check. What can I plug in here? 2. What can I plug in here? 1. There are our 2 solutions. So x can equal 2, x can equal 1, and the entire equation will equal 0. All right, so we've solved quadratic equations with just regular solving. We've solved it with factoring because we had two x values. Let's try this ugly guy now. How the heck are we gonna solve this guy? Well, we've got x's all over the place. Do you know a certain type of factor we could use with 1, 2, 3, 4? That doesn't look like grouping. The only thing we can do here is expand. We've got to simplify this before we figure out how we're going to solve it. So I'm going to simplify it by expanding it here. I'm going to expand this guy, and let's see what we've got. This is going to be 15x squared, and then we have minus 12x plus 2x is equal to x squared minus 4x plus 12. All right, I'm going to bring everything to one side because I know I'm probably going to have to factor this guy. So I'm going to bring everything onto the left side. So I'm just going to do this in my head. I'm going to have 15x squared, and then I'm going to take away an x squared. So I'm going to have 14x squared. And then I have negative 12x. I'm going to bring this negative 4x over, and it's going to be positive 4x. You know what, this one I'll write out so you can see it all. We have positive 4x, and then we still have a plus 2x, which is right here. And then we're bringing that negative 12, positive 12, we're bringing it over, it's going to become negative 12. So I have 14x squared minus 8x, oh no, not minus 8x, because, forgot something. We've got negative 12 plus 4 is going to be negative 8, plus another 2 is going to be negative 6x, and then we have minus 12 equals 0. Now we're left to solve this guy. This looks much easier to solve. Now we've got a simple trinomial. So it went from this ugly thing to just a simple trinomial. So we can try solving this by factoring first. I notice that there's a common factor, it's 2. Instead of common factoring out of 2, I'm actually just going to divide by 2. And the reason I can divide by 2 is because I have an equation here. So I can introduce this new number 2 as long as I do it to both sides. So I'm going to divide by 2 on this side and divide by 2 on this side. And I'm going to have 7x squared minus 3x minus 6, and that's just equal to 0. So now these numbers are a little bit nicer. Let's see if we can factor it. So we're looking for two numbers that multiply to negative 42 and add to negative 3. And unfortunately, those numbers just don't exist, which means we can't factor this. And so we're stuck and we're left with our final tool with solving quadratics, which is the quadratic formula. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. And if we remember from grade 10, that a, b, c, those are just the coefficients of x squared, x, and our constant term. So this guy here, that's our a value. This guy here is our b value. And this guy here is our c value. So let's fill in what we know. So we're going to write x is equal to negative b, so that's going to be negative 3, plus or minus the square root of b squared, that's going to be negative 3 all squared, minus 4 times 7 times negative 6, all over 2, our a value is 7. Let's simplify that some more. So our next step is we're not going to put this all in the calculator, we're going to keep this in exact expression. So what we're going to do is I'm going to calculate what's under the equal sign, under the square root sign only. So I'm going to calculate negative 3 squared minus 4 times 7 times negative 6. So, oops, let's change this. There we go. So I have x is equal to negative 3, just positive 3, plus or minus the square root of, we have 177 all over 14. So let's see if we can simplify this root anymore. In grade 10, we'd probably go to our calculators now and get a decimal. Now that we know how to simplify roots, we're going to leave this an exact answer. So is there a perfect square that goes into 177? Try. Does 4 go in? Well, obviously not, because 77 is an odd, or 177 is an odd number. How about 9? Unfortunately, there's no perfect squares that go in there, and so we're going to leave it alone. So this is an acceptable answer because we can't reduce the 3 and the 14. We can't simplify this at all, so we're done. If we want to, we could write it as 2 separate answers. So we have 2 answers for x. Our first value of x, or our first solution, is 3 plus root 177 over 14. And our second option, or our second value of x, is 3 minus root 177 over 14. Let's try our final example. This one gives us an equation, but not, it's not an equation that we can solve because we've got 2 variables here. It says find the x-intercepts. We know how to find x-intercepts. Every time it asks us to find x-intercepts, another way to say that, by the way, is just zeros. Zeros. I don't know if there's an e there. I'm going to just say there's no e. Okay, so that just means we got to sub in y equals 0. Every time we have to find a 0 x-intercept, that's going to be our first step. Just sub in y equals 0. So let's do it. We have y equals 0, and then we have 2x squared minus 13x minus 7. All right, now this is an equation we can solve. Let's choose this. We got to do factoring, or we have to do the quadratic formula. Factoring is faster, so I'm going to try it. We got 2 numbers that multiply to negative 14 and add to negative 13. Do they exist? Well, how about 14 and 1? How about if we put a negative in front of there? We've got negative 14 times 1, that makes negative 14. We've got negative 14 plus 1, that makes negative 13. All right, let's do decomposition. So we got 2x squared. Let's break up that negative 13 to negative 14x plus 1x minus 7. We're going to group them in common factor, so we can take out a 2x. We can take out a 1. Magic has happened. We have a new common factor. So we're going to take out that common factor, and we're left with 2x plus 1. All right, so the whole thing is equal to 0. It's factored, so I can guess and check my solutions now. This guy, if x is equal to 7, 7 minus 7 will make 0. That will be one of my answers. So x1 will be 7. So that is the first x-intercept. I plugged in y equals 0. I got x equals 7. Let's figure out the second x-intercept. The second x-intercept is going to be negative 1 over 2. If you're still having trouble finding that, remember, just set that guy equal to 0. Set 2x plus 1. What if it had to equal 0? What would x have to be? Bring that 1 over, so I have 2x is equal to negative 1. Divide by 2, divide by 2, and I have x is equal to negative 1 over 2. And that's how I got this guy. So here are 2 x-intercepts, and we're done. So next time we have to solve quadratic equations, even if you get a crazy one, don't freak out. Remember, you got 3 tools you can use. You can use regular solving, you can use factoring, or you can use the quadratic formula.